Welcome back to the Deep Dive. We are doing something a little different today. Usually we talk about the future of technology as something that's, 5, 10 years down the road.
Right.
But today we are looking at a stack of software that you can download right now, tonight, that fundamentally changes how creative media is made.
It really is a right now revolution.
Yeah.
I mean, we aren't talking about cloud servers or subscription fees. We are talking about converting your gaming PC into a localized, private, creative studio.
We've all heard that term, bedroom producer, right? The kid with a laptop making beats.
Sure.
The sources we have today suggest that concept is dead. Or, well, it's evolving into something much more intense. We are moving to the data center producer.
That's a great way to frame it. Because the capabilities we're seeing in the open source community, specifically with this new stack of tools, allow a single person to generate not just a beat, but a whole cohesive studio quality concept album.
The whole thing.
Lyrics, vocals, instrumentation, mixing, all of it, all offline, all on consumer hardware.
And to guide us through this, we have two main characters in our story today. First, we have the engine, a model called Ace D-Step, specifically versions 1.5 and 2.5.
And then you have the conductor, this multi-agent system called SongBird.
And the mission here is it's fascinating. It's all about local first creation. It challenges those big proprietary giants, like Suno or Udio.
It absolutely does. It says you don't need a massive server farm to make great music. You just need smart architecture. But, and we have to get into this later, it also opens up a massive can of worms with ethics and attribution.
Right, the whole fair AI media framework, we will definitely get there. But let's start with the hardware. I think a lot of people assume that to run a music generation AI, you need like an NVIDIA H100 that costs $30,000.
Yeah, that's the common wisdom.
But the benchmarks for A-Step are surprising.
They are shockingly efficient.
Yeah.
The documentation for A-Step, it highlights that it can run on consumer cards with as little as 4 GB of VRAM.
4 gigs? That's an entry-level laptop card from like 4 years ago.
Exactly. Now, obviously, if you have an NVIDIA A6000, you're going to fly. You can generate a 3-minute track in about 30 seconds.
Wow.
But the fact that it runs at all on low-end hardware is the democratization aspect.
Yeah.
It means the barrier to entry isn't money anymore. It's just the willingness to install the software.
Okay, so let's pop the hood on A-Step. What is actually happening inside this model? Because historically, local music models have been, well, they've been bad.
Oh, terrible. They usually sound like a radio losing signal after maybe 20 seconds.
Yeah.
That's the coherence problem. Most older models are diffusion-based in a way that just consumes memory way too fast. They lose the context of the beginning of the song by the time they get to the chorus.
So how does A-Step fix that?
It uses a hybrid architecture. It combines a deep compression autoencoder, a DCAE, with a really lightweight linear transformer.
Okay, let's break that down. Deep compression autoencoder. Is that like an MP3 file on steroids?
Sort of. That's a good way to think about it. An audio file is heavy, right? It has thousands of samples per second. If a transformer tries to predict every single one of those samples, it gets totally overwhelmed.
This is too much data.
Way too much. So the DCAE zips that audio into a highly compressed mathematical representation of latent space that keeps all the musicality but drops the heavy data weight.
So the transformer isn't writing audio, it's writing the instructions for the audio?
Precisely. The linear transformer predicts the flow of these compressed tokens. And because the data is so much smaller, the model can see much further back in time without running out of memory.
Ah, so that's why it's coherent.
That's how ACE-Step can generate tracks up to 4 minutes long that actually remember the main melody from the intro when they hit the outro.
That's the key insight right there. It's not that the model is smarter, it's that the data is lighter, so its memory is effectively longer.
That's it in a nutshell. And we're talking about the 3.5 billion parameter model here. In the world of text LLMs, 3.5B is tiny.
Right, it's nothing.
But in audio, because of this DCAE architecture, it punches way, way above its weight class. It creates full song structures, verses, choruses, bridges that feel intentional, not just random.
But here's the catch. I was reading the ACE-Step 1.5 Architect Prompting Guide, and this is not ChatGPT. You can't just say, "Make me a cool funk song."
No, and honestly, that's a good thing for power users. It requires a cockpit mindset. To get those studio-grade results, you have to follow a very strict protocol.
How strict?
The model expects a specific string order for the main caption. Style, then gender vocal type, emotion, lead instruments, and finally, vibe. in that order.
And if I mix that up, if I put vibe
The
first,
model gets confused. It has been trained to associate the position of the word with the weight of the instruction. It's like syntax encoding. You can't just throw variables wherever you want.
and then there are the lyrics. This part blew my mind. The documentation talks about punctuation as breathing.
This is one of those details that reminds you how weird AI actually is. The model uses punctuation marks to control the AI singer's lungs. A period acts as a full stop, a deep breath.
And a comma.
A comma is short pause, a little catch breath.
So if I just copy-paste a block of text without any punctuation,
The AI will try to sing the entire verse in one continuous breath. It sounds rushed, frantic, and eventually the audio quality just degrades because the model is, metaphorically, running out of air.
you have to act like a vocal coach. You're literally placing the breaths in the code.
You are. And you also have to use these structure tags like chorus anthemic or verse laid back.
So you're directing the energy flow.
Yes. And you have fine-grained control over the metadata, too.
Mm-hmm.
You can set the BPM, the time signature. You can force a 34 waltz or 68 swing, and the key scale. If you want C minor, you get C minor.
That really separates it from the slot machine generators where you just pull the lever and hope.
It feels less like generating and more like programming music.
It is programming. But that brings us to the friction point, right? Managing all of that, the punctuation, the tags, the metadata, the string order, that's cognitively expensive.
Oh, it's exhausting to do that for 10 songs in a row.
Which is why we need a conductor. Enter SongBird.
Right. SongBird is the answer to the fatigue of manual prompting.
The source code describes SongBird as a multi-agent system based on LangGraph. For the non-coders listening, what does that actually mean for the workflow?
It means you aren't the one sweating over comma placement anymore. You are the executive producer. SongBird spins up a committee of specialized AI agents.
So it's not one big brain trying to do everything.
No, you have distinct agents with distinct roles, and they all talk to each other.
I love this concept. It's like creating a virtual band. So let's meet the members. Who are we hiring?
First, you have the artist agent. This agent's job is purely creative direction. It creates a persona. So if you tell SongBird, I want a 90s grunge track, the artist agent might generate a fictional character, say, Jax, a 24-year-old from Seattle who hates commercialism.
It builds a backstory.
It builds a vibe. It selects the stylistic inspirations that fit that specific character. Then it hands that profile off to the music agent.
And the music agent is the theory nerd.
Exactly. The music agent looks at Jax from Seattle and translates that into technical specs. It just says, okay, Jax needs a BPM of 95, a distortion-heavy guitar tone, and we should probably be in like a drop D tuning equivalent. It handles all the ACE step metadata.
And then we have the lyrics agent. Now, I've seen AI lyrics before. They're usually terrible. Just, I love the cat looking at the bat kind of stuff.
Rhyming dictionary nonsense.
How is this different?
The SongBird lyrics agent is actually a multi-stage pipeline. It doesn't just guess words. It performs what it calls deep research. The source mentions it uses the Perplexity API and LightRag.
Wait. It has internet access?
The agent does. It goes out and researches the topic.
Yeah.
So if you ask for a song about the fall of Rome, it doesn't just hallucinate. It looks up historical figures, specific dates, and thematic elements. Then it drafts the lyrics.
And it handles that punctuation as breathing rule we talked about.
That's its main job. It formats the lyrics specifically for AC step, inserting the breath marks and the structure tags. And it iterates. It has a refinement stage to improve flow and give it what the developers call street quality.
So it doesn't sound like a robot reading a Wikipedia page.
Exactly.
That is a massive leap. So you have the artist setting the vibe, the music agent on theory, and the lyrics agent doing research and formatting. How do they stay in sync?
They share a song state. It's like a project file that gets passed around the room. It ensures that if the artist agent decides the mood is depressing, the music agent picks a minor key, and the lyrics agent writes sad words.
It prevents that weird disconnect you sometimes get with AI where the lyrics are happy, but the music is, like, terrifying.
Right. And there's one feature in SongBird that I think really differentiates it from just a playlist generator.
Album mode.
This is the killer feature for narrative consistency. Usually, if you generate 5 songs with AI, they sound like 5 totally different bands. SongBird's album mode tries to create a concept album.
How does it know what happened in the previous song?
It has a sequential memory. When SongBird generates a track, it saves it. When it goes to generate the next track, it scans the output directory. It literally extracts themes and lyrical snippets from the previous songs
No way.
and injects them into the prompt for the new one.
So if song 1 ends with a character leaving town,
Song 2 can actually start with them on the road. The source gives an example of a space opera about a lost pilot, and you get a logical arc. Launch, malfunction, crash, survival, all sharing the same musical DNA because the artist agent is consistent, but the narrative evolves.
That is the difference between a toy and a tool. Now let's talk about how the user actually sees this. We've mentioned ComfyUI. For those who haven't used it, it's that node-based visual interface. It looks like a bowl of spaghetti made of wires.
It is intimidating at first glance, I'll give you that, but it gives you a level of control that a simple chat window never could. You're literally chaining nodes together. Load model data agent, prompt audio, decode.
So where's the magic?
The magic in ComfyUI is the post-production, specifically in painting.
This is so crucial for anyone who has actually tried to make AI media. You always get a great generation, but there's one weird glitch. A vocal crack or a nonsensical word.
And in the old days, like 6 months ago, you had to just regenerate the whole song and lose all the good parts.
Right. And pray you get lucky again.
With AC Step in ComfyUI, you can mask out just that 3-second glitch. You tell the AI, keep everything else, just re-sing this one line.
That's the Photoshop moment for audio.
It is. And you can do extensions too. If you generate a chorus you love, but it ends too abruptly, you can feed the last 10 seconds back into the model and say, continue this motif for another minute. You can build a song brick by brick.
I also saw in the SongBird source code that there are CLI arguments command line stuff. You can actually override the agents.
Yes. It's this great mix of autonomy and control. You can run SongBird and say vocals female to force a gender, or vocals choir, or you can use vocals auto and just let the artist agent decide what fits the vibe. You're never locked out of the process.
Okay, so we have this incredible power. We can spin up a virtual studio, produce a concept album, research historical lyrics, and run it all locally on a gaming card.
Right.
But we have to pivot here. We have to talk about the elephant in the room.
The training data.
The training data. These models, AC Step, the underlying LLMs, they are trained on human music. They are standing on the shoulders of giants. And usually those giants aren't getting a check.
It's the biggest friction point in the entire industry. And this is where that fair AI media vision comes in. The sources we looked at reference a paper from Mixaudio and Newtune. They're proposing a totally different way to handle this.
They call it a move to a post-streaming economy. What's so wrong with the current streaming economy?
It's opaque. It's a black box. You pay Spotify, Spotify pays a pool, the biggest artists take the lion's share, and niche creators get fractions of a penny. You can't trace exactly where your money went.
So what's the new proposal?
The Fair AI proposal argues for an agentic ecosystem based on block-based attribution.
Block-based. So are we talking about blockchain? Or just like building blocks?
Think Lego bricks. They envision a system where music isn't treated as a single .wav file, but as granular block stems, structural segments, specific drum loops, synth patches, all stored in a block DB.
Okay, so it's a database of ingredients.
Exactly. And here's the shift. When an AI agent, like our music agent in SongBird, decides it needs a snare sound, it retrieves a specific block from that database. That action triggers an attribution event.
It logs the usage in real time.
Yes. Agent X retrieves block Y created by human Z. It embeds the provenance and the copyright tracking directly into the generation workflow. They call it RAG for audio, retrieval augmented generation.
That is a massive conceptual shift. Currently, we try to sue people after the song is released if it sounds too similar. This creates the paper trail during the creation.
Transparency by design. It moves us away from the fear of AI stealing art to a model where AI becomes a licensing engine for human art. If your drum loop is the best one in the database, agents will use it 1 million times and you get credited 1 million times.
It turns the AI from a thief into a distributor.
Theoretically. I mean, obviously, getting the entire music industry to agree on a standard block DB format is a Herculean task. But the technology to do that, the logging, the array, the attribution, is being built right now alongside these generation tools. It's a vision where the source material is respected, not just scraped.
So bringing it all back together, we have AC Step giving us studio quality audio on our local GPUs. We have SongBird turning us into executive producers of these little AI teams.
Right.
And we have this fair AI media framework suggesting a way to make it all sustainable.
We are at a convergence point. For a long time, you had to choose. Do you want it to sound good, which meant using the cloud and losing privacy, or do you want control, which meant using a weak local model? AC Step 2.5 proves that consumer hardware is enough. And SongBird proves you don't need to be a prompt engineer to get great results.
You just need to manage the agents.
Yeah.
It really redefines the role of the creator. And that leads me to something I've been wondering. As these agents get better, as the artist's agent gets better at creating personas and the lyrics agent gets better at deep research, what happens to the human user?
That is the big question. If the AI is writing the lyrics, composing the melody, and even feeling the vibe through its persona,
Hmm.
are we really creators anymore? Or are we just curators?
Or maybe managers?
Manager is probably the most accurate term. You are managing a roster of digital talent. You're approving their drafts, sending them back to the studio, tweaking their output. But there's a provocative thought here. As these systems get more and more autonomous, creating their own albums, maybe even managing their own block libraries,
Hmm.
at what point do they start curating us?
Oh, run that by me again.
Think about it.
Hmm.
If the system knows what blocks are trending in the database, and it knows what lyrics flow best based on millions of data points, it might start nudging your prompts. You say, I want a slow ballad. The agent says, actually, the data suggests an upbeat tempo works better for this demographic right now.
So the tool starts shaping the artist. We become the client, and the AI becomes the record label executive telling us what will sell.
Precisely. We optimize for the algorithm, and the algorithm optimizes for us. It's a feedback loop that might be very hard to escape.
That is a terrifying and exhilarating thought to end on. If you're listening to this and you have a decent GPU, I highly recommend finding the GitHub repos for SongBird and ACE Step. Try it out. See what it feels like to manage a team of AI creatives.
Just make sure you keep an eye on who is actually running the session, you or the agents.
And keep those GPUs spinning. Thanks for diving deep with us. We'll catch you on the next one.